This lecture is for Living Earth, continuing with Unit 1.1, the Earth's spheres. We're continuing to add to our response to the essential question, what are the major components of the Earth system? We have already covered the geosphere, the hydrosphere, and the atmosphere. And today we'll finish up this subunit by talking about the biosphere. The biosphere. The biosphere consists of those parts of the planet where life exists. It forms a narrow layer ranging from about 11 kilometers beneath the ocean surface to about 9 kilometers into the air. So even though that seems like a long distance to us humans, relative to the size of the Earth, that actually is a very narrow or a very thin layer around our planet. Thus, the biosphere consists of parts that include the geosphere, the hydrosphere, and the atmosphere that we've already talked about. And so the biosphere is intermingled with those other spheres. So why does life exist where it does on the Earth, and why does it not exist in other places? The most important factors are the existence of liquid water and the flow of energy. Earth's atmosphere allows enough solar radiation to reach the planet's surface to maintain an average global temperature of about 15 degrees Celsius. With less solar energy, so if there was less sunlight or less solar radiation, Earth would become too cold for life to exist, like Mars has. But if there was more solar radiation, the planet could become too hot, like Venus is. So in terms of energy, Earth is an open system, which means that the planet is continually gaining and losing energy. In terms of matter, however, Earth is considered a closed system. While organisms live, they absorb nutrients from their environments. And when they die and decompose, the matter that makes up their bodies returns to the environment. In this way, the biosphere is continually replenished to make way for new life. A huge diversity of organisms linked by food webs and other relationships are involved in this process. And the maintenance of a healthy biosphere, therefore, requires the careful stewardship of high levels of biological diversity. Earth's magnetic field. Earth's magnetic field. Earth is exposed to material that is being ejected constantly from the sun's surface. This material moves like wind through space. The interaction between charged particles in the solar wind and Earth's magnetic field produces a barrier of space around the planet, and this barrier deflects most of the charged particles that are ejected from the sun. This barrier is called the magnetosphere. The bow shock describes the frontal blast of the ions as they approach Earth. The charged particles are heated, which slows them as they deflect around Earth. As the ions pass the planet, the magnetosphere expands to 1,000 times Earth's radius, producing the magnetotail. Forming the magnetic field. Forming the magnetic field. Earth behaves like a dipole magnet, which is similar to a common bar magnet. Scientists think that the planet's magnetic field is produced by Earth's core. The molten iron and nickel in the core circulates as the planet rotates. This circulation produces a magnetic field with poles near the planet's north and south poles. Magnetic field lines help us visualize this magnetic field because we cannot otherwise see it. They indicate the strength and direction of the magnetic field. Currently, the magnetic field lines exit the magnetic south pole and travel around the planet, where they then enter the magnetic north pole. Because the magnetic field lines enter at the magnetic north pole, the arrow on a compass points north. Solar wind. Solar wind. The solar wind consists of charged particles, which are called ions, that are ejected from the sun's upper atmosphere. These particles, these ions, flow away from the sun at about 400 kilometers per second, but they can vary in speed from anywhere from 300 to 800 kilometers per second. Earth's magnetic field deflects the ions around the planet like water deflected around the bow of a ship. The shape and size of the magnetic field is defined by the strength and speed of the solar wind. The magnetic field protects the planet from these high energy charged particles. This protection has allowed life on Earth to develop and survive. A small amount of the charged particles in the solar wind become trapped in Earth's magnetic field. These particles form the Van Allen belt, which exists about 6,400 kilometers above Earth's surface. That'll do it for this lecture. At this point, we have covered the geosphere, the hydrosphere, the atmosphere, and now we have covered the biosphere. So at this point, you should be able to construct a full and complete response to the essential question, what are the major components of the Earth system?